Hello peoples. This is the question I'll go on to today. Tree Longest ZigZag question in Codility. It is to find the largest number of zigzag, which means turning direction left to right or right to left, occurring on every downward travel inside given binary tree. Okay, let's draw a binary tree like this. I'll not input value here because it is not a big matter in this question. Okay, let's go into every downward travel. First will be this. In this travel, direction is left, left, and left. So zigzag number in this travel is 0. Okay, let's remove this. And next, the travel will be, it is not left. It starts right and goes left. So there are 1 zigzag. Okay, let's go into this one. It goes from right, right, and left turn, and right turn. So there are 2 zigzag. One is here, and one causes here. So there are 2. The last trip will be here. The trip will be right, right, and right. So there are no zigzag. So in this cases, the maximum zigzag count we need to know is 2. Following this approach, we should go inside every branch until end node. Let's make depth first search logic in a recursive way. Function here, DFS, will be called recursively during logic. First, we need tree data as first parameter to send child node. Second data will be current zigzag count, ZZ here, and last should be direction information to define whether current move is zigzag or not, which means it is moving left to right or right to left. And it should return maximum zigzag count during the call. Starting from head of tree, first, check whether there are a left child node. And if there are, call DFS function again with sending left child as first parameter. If direction information is right, it means it zigzags right to left. So define cur to keep the current zigzag value, and if the direction is right, then add 1. Recursion will go through until there are no children, and it will keep return current max zigzag when called. Let's give the function, let's give the parameter for the DFS here. Tree will be tree left and give current zigzag count, and we're gonna go to the left. The direction is left, so give left for the direction. Recursion will go through until there are no children, and it will keep return current max zigzag when called. So compare current count with recursive result. Like this, compare it, and keep max value here. Okay, this is for left children, and let's make opposite logic for right child node and do it same. Keep current zigzag count and compare the direction. Okay, the value will be same as the left cases, but a bit different in the parameter. We will send the right children of tree, and the direction will be right. And also keep max value here. So the answer will be the final result here. Okay, let's go into coding. First, check technical detail here. And class tree looks like following. It has X as node value, and left tree and right tree. As designed just before, let's make DFS function here, which should return integer. So parameter are tree object, current zigzag count, and direction. Let's define direction as integer here. -1 as left and 1 as right. Okay, here, add a comment. Okay, and because first turn from root should not be counted, so let's define one more, 0 as neutral status. Okay, let's start here. Keep current maximum value, max, with given zigzag parameter. And if left child is not null, add new variable to keep new zigzag count inside here. New zigzag is, okay, changing name. Yeah, new zigzag equals zigzag. So if direction has been changed right to left, then add 1 here. Okay, so we got required parameters for DFS function. We should go into left child. So throw left child tree object here, and newly calculated zigzag count. And we've checked left is not null for now, so direction is -1, which means left. Okay, now compare the value of recursively calculated result and current maximum value. Call math.max and give DFS function as first parameter and max as second one. and the maximum one will be the new max value. Okay, let's do the same thing for right child. Okay, this is to check the right child. So the direction we need to check is -1 left. Then add 1 to new zigzag count and compare the value between the recursive function result, which is throwing the right child of the tree, and other thing is same, and get the maximum value of the compared result. So DFS logic is done. Return current maximum value at the end. Okay, solution is done. Just return the result calculated from DFS function. Send root node as a tree parameter. Zigzag is 0 and direction should be neutral. And to guard exception cases, check whether root is null. In this case, we only need to return 0 because there are no zigzag. Okay, run the code. Okay, works properly on the example test. And then submit it. It takes some time. Great, it has passed all tests. You can see the result here. This solution takes O and time complexity because it travels every node once. So time will be increased by number of nodes linearly. And for space, we have OH complexity, which H means height of the tree. If binary tree is fully balanced, height will be log n. So in big O notation, it has O log n space complexity. So this is it. Thanks for watching it, and see you in next video.